Okay, so let's continue our discussion now in this video. So let's try naman FEM for two-dimensional. So FEM for two-dimensional 2D. Focus tayo sa constant strain triangle. Constant strain triangle. From the word constant na strain. Sabihin, yung strain sa element na to will be constant. So yun lang yung disadvantage niya, no? Alam naman natin in reality hindi naman dapat constant, because it varies along the body. Kaya the triangular shaped element like this should be used dun sa masyadong maliliit na mesh. Okay? For example, meron kang may hole, yan, na say two-dimensional na plate. So, diyan ka maglalagay ng triangle, no? Maliliit, no? Okay, para hindi masyadong malaki yung ano mo, yung error mo. Okay. So, diyan madalas ginagamit ang triangle. Okay. Pero even that, malaking, very useful itong shape na to, element shape na to. So again, you referring to our reference here. Okay, shape function using Cartesian coordinates. Okay. So polynomials are the easiest way of mathematical operation for expressing variation of displacement. For example, the displacement variation within the element can be represented by the following function in case of 2D plane stress or strain problem. So na-capture ko na to. So sa 2D plane stress strain problem, we assume na meron kang displacement at each node. Okay. Using this, lumalabas, meron tayong 2 displacement at each node, U and V. Okay. And yung U, parang sa beam and sa axial, we assume this with this displacement function. Well, for V, ganun din naman, no? Alpha naught plus alpha 1x plus alpha 2y. Okay. First that, insert, kumbaga, say ito yung body mo. Okay, so, and each node, meron kang dalawang displacement. Yan, so U, V. U, V. So, U1, V1, U2, V2, U3, V3, okay, U4, V4. Okay, parang ganyan, no? Now, using our element, pwede mong hatiin to, no? So, element 1, element 2. So, i-mesh mo siya. Okay. And this is normally used in plane stress or strain problem. Okay. Okay. So, balik tayo sa ito. Yan. Kinapture ko na siya. So, yun. So, alpha naught plus alpha 1x plus alpha 2y. Okay. Now, alpha naught, alpha 1, alpha 2 are unknown constant coefficients. So, kagaya ng sa beam and axial member. Thus, the displacement vectors at any point P in the element can be expressed with the following relation. So, familiar na tayo dyan, no? Okay. If you express in matrix form yung equation 3.2.1 sa 3.2.2, ganito yung itsura niya. from alpha naught, okay, alpha 1, alpha 2, hanggang alpha 5 na unknown constants. Or, in simple form, the D matrix is equal to phi matrix times the alpha. Okay? Next is, ito yung drawing ng ating triangular element having 3 nodes, of course. Okay? So, meron siyang coordinate na x1, x1, y1, x2, y2, and x3, y3. Okay. Now, kung sakaling 3 degrees of freedom, ito naman yung lalabas, equation 3.2.6. Now, stick ngayon tayo sa 2 degrees of freedom. It can be written in terms of the nodal displacement as follows. Yan. So, tingnan nyo yung 3.2.7 na equation. So, which is this one. Okay? So, dahil meron tayong 3 nodes, you have U1, U2, U3, and V1, V2, V3. So in matrix form, yan, no? D equals the D matrix, which is in expanded form U1, U2, U3, V1, V2, V3, will now be equal dun sa matrix na yan, 1, x1, y1, 0, 0, 0, then alpha naught hanggang alpha 5. Okay, so parang pinahaba lang natin ito. Okay. Okay. UV. Okay, that's it. Okay. Now, where D is a nodal displacement. Now, to simplify the above expression for finding out the shape function, the displacement in x direction can be separated out, which will be as follows. So, extract natin yung upper matrix. No? Yung focus lang tayo sa U1, U2, U3. And then, syempre, ang involved sa kanya is alpha naught, alpha 1, alpha 2. So, extract lang natin ito. Ito ang extract natin. Yan. Yan. So, ito yung involved sa kanya, no? Yan. Yung mga yan, no? Yan. So, U1, U2, U3, 1, alpha naught, alpha 1, alpha 2. So, pwede natin gawin yan, no? Kumbaga, ang tawag dyan is the submatrix, no? Submatrix, okay? Where these are nodal displacements, to simplify the above equation, ito na nga yan, no? Okay. Okay. So, balik tayo dito, no? Our U1, U2 na in-extract natin doon sa taas will be alpha naught, alpha 1, alpha 2. Now, to obtain that unknown coefficients, yung parang ginawa natin sa P, get the inverse, no? Inverse nito. So, we need to get the inverse nito, which is this here. Yan. Yan. So, alpha naught, alpha 1, alpha 2 equals, yan, get the inverse of that in U1, U2, U3. It turns out, yung inverse na yan is ito. Yan. No? 1 over 2a, okay, x2, y3 minus x3, y2. And I'll make a separate video na lang, no, how to derive that. No? Pero for now, let's just believe na of this equation na to, no? Okay. Definitely, totoo to, no? Definitely, this is correct. 1 over 2a, x2, y3, so blah, blah, x3, y1, minus x1, y2. Okay. So, extract natin yung 1 over 2a. And, dahil mahaba yung nasa loob, let's just assume yung x2, y3 minus x3, y2 is simply equal to a1. And then yung x3, y1, x1, y3, ito. Yan, ito. x3, y1 minus x1, y3 is simply equal sa a2. Okay? And of course, A is the area of the triangle and can be obtained as follows. So, alam na natin yan during undergrad pa lang. Okay. Okay. So, pag ito, no? 1 over 2a, okay, x2, y3 minus x3, y2. Take note, everything here, no? They are all in terms of coordinates ng triangle, ng ating element. Okay? Walang variable dito na lumalabas, no? Okay? Except ito, syempre, yung unknown displacement. Yan. So, 1 over 2a, a1, a2, a3. Okay? Now, if we expand yung u, it will be like this. 1 over 2a, x2, y3, okay, u1, 1 over 2a, u2. Okay. We know that u is equal to n, the u. Okay. Ni, ui. Okay. Shape function. These are the shape function. Okay. So, ganyan basically yung concept ng FEM, no? We introduce a shape function to an unknown displacement. Okay. So, thus the interpolation function or the shape function is this, n1, n2, n3, and it turns out, ito yun, no? Yung tatlo, no? Nakikita nyo naman, yung pattern. 1 over 2a, x2, y3, x3, y2, y2, y3. That's it. Okay. That is our n. No? Now, such three-node triangular element is commonly known as constant strain triangle. Okay. As its strain is assumed to be constant inside the element. Okay. Now, strain x, strain y, and then itong ating shear deformation xy. Shearing strain rather, xy. So, from the discussion of elasticity, alam mo na to dapat, no? Yan. Okay. For strain x, syempre, du dx. Okay. So, along with the direction of x, no? While strain y, sa direction naman ng v, no? dv dy, no? Then, shearing strain, dv dx plus du dy. Okay. So, simply find the derivatives or partial derivatives of u. Okay, ang u natin, if you remember, is alpha naught plus alpha 1x plus alpha 2y, di ba? Alpha naught plus alpha 1x plus alpha 2y. That is our u. While our v is alpha 3 plus alpha 4x. Okay. So, save ko muna. Ayan, no? Ito. So, u is alpha naught plus alpha 1x plus alpha 2y, while v is alpha 3 plus alpha 4x plus alpha 5y. So, du dx equals, so x is the variable, so a1. This is our constant, no? Constant. Okay, while dv dy, okay, constant. So, alpha 5. Okay, which is this. Okay. Now, shearing strain xy, dv dx plus du dy. So, dv dx, ito yun, no? So, alpha 3 constant, okay, that is alpha 4. Then, alpha 5, y is constant. While du dy, ito yun, ha? equals, so get, so this becomes now constant, no? So therefore this is alpha 2. Therefore yung shearing deformation or strain is alpha 2 plus alpha 4. Okay, so that is important later on para sa ating example problem. So we already know the shape function in forms of this, and then the strain in terms of this. Okay, so to continue, so we stopped here earlier. Yeah, now remember strain is this, strain x, strain y, and shearing strain, and strain x is du dx. Okay, but take note, our u, as I mentioned earlier, u is actually n1 u1 plus n2 u2 plus n3 u3, or in simple form ni ui, diba? Okay, now so to substitute that here, so du dx is simply dn1 u1 dx plus dn2 u2 dx plus dn3 u3 dx. Ganon din sa dv dy. dv dy is dn1 v1, dn2 v2, dn3 v3. So ganon din dito, du dy is dn1 u1, dn2, so okay, so on and so forth. Or in matrix form, so in matrix form ito is dn1 dx, okay, 0, 0 yan, no? Kasi ito ang coefficient lang nito is u1, u2, u3. Okay, therefore, hindi involved dito ang v1, v2, v3. Okay? Now, strain is BD. Okay? Strain is BD. Therefore, this is our D, which is the unknown displacements. This is our D. Therefore, this is our B matrix. Okay? Next, we know from here, from the previous topic earlier, this is our N matrix, no? So, dito siya ulit. Yeah, okay. And we know that the B matrix is this. So, we need to get the partial derivatives of our N matrix. Okay. So, dn1 dx, dn1 dy, so on and so forth. Okay. Okay, so ito yon, yung N matrix natin. Or in another form, ito yon. Designating na itong alpha 1 na to is this one. Okay. Itong beta 1 na to is this one. Okay, dito yun. So, baba. Hence, the required partial derivatives of shape functions are this. For example, dn1 dx. Gawin natin. dn1 dx, which is ito. Ito yung dn1. Or ito. So, get the partial derivative of that. dn1 dx is equal to, remember, constant lahat to, no? In terms of coordinates to mga to, no? So, dahil dx, so constant to. Constant yan. Yeah. Okay. dn1 dx is simply beta 1 over 2a, which is ito. Okay, how about dn2 dx? Again, constant